Hi everyone, welcome to Educon community. And we already have started the Java crash course. We have discussed the history of Java, and now we are going to start with the features of Java. So, first of all, the primary objective of Java programming language creation was to make it portable, simple, and secure programming language. And apart from this, there are also some excellent features which play an important role in our uh, uh, societies, like making some great enterprise applications wherever, like in web applications or mobile applications or desktop applications, everywhere you will can uh, see. And apart from this, it also play an important role in the popularity of this language. So the features are the backbone for this popularity. And the features of Java are also known as the Java buzzwords. So the main key features of Java are like simple, object oriented, portable, platform independent, secured, robust, architecture neutral, interpreted, high performance, multi threaded, distributed, and dynamic. So, first of all, simple. So Java is very easy to learn and its syntax is simple, clean, and easy to understand. So according to Sun Microsystem, Java language is a simple programming language. Why? The reasons are like Java syntax is based on the C++, so easier for programmers to learn it after C++, usually in schools and colleges. First of all, C++ is there in our syllabus, and after that, one will move to the Java or other languages. So whenever you will learn the C++, after that, the to learn the Java is very easy according to syntaxes. And Java has removed many complicated and rarely used features. For example, explicit pointers, operator overloading, these things, which you can see in C++, like the operator overloading. But Java already removed these complicated and rarely used features. And there is no need to remove unreferenced objects because there is an automatic garbage collection in Java, which will remove the unused or unreferenced objects automatically. Next one is object oriented. So Java is an object oriented programming language. So everything in Java is an object. And in program, you will see like human or person, all things are objects. So object oriented means we organize our software as a combination of different types of objects that incorporate both the data and behavior. So you know, right? In car, so you will collect the data like what is the age of the car, what is the color of the car, what is the model of the car. Okay, so these things are the data of the car, and also it has the behaviors. What are the behaviors? Like in the car, we can play the songs. In the car, we can drive the uh, car, like driving. Then we can accelerate. We can do the brake. We can apply the brake like that. So those things are the behavior of the car. So both data and behaviors are there. So those are the objects. So in this way, we will organize our code using the classes, objects, inheritance, polymorphism, abstraction, and encapsulation. So these are the basic concepts of OOPS. What is OOPS? Like object-oriented programming system. So these are the building blocks or the pillars, you can say, are like classes, objects, inheritance, polymorphism, abstraction, and encapsulation. These are the building blocks of Java. And it also simplifies the development and maintenance. Next is platform independent. So write once, run anywhere. Bora. So Java is basically platform independent because it is different from other languages like C or C++, which are compiled into platform specific machines, while Java is a write once and run anywhere language. So a platform is the hardware or software environment in which a program runs. So there are two types of platforms: softwares based, platforms, software based, and also hardware based platform. So Java provides a software based platform, and the Java platform differs from most other platforms in the sense that it is a software based platform, not the hardware based platform. So it can run on top of other hardware based platforms. So it has basically two components. First one is runtime environment and second one is API, means application programming interface. So Java code can be executed on multiple platforms like different operating systems, Windows, Linux, Mac, like that. So Java code is compiled by the compiler, and after the compilation, it is converted into the bytecode. And that bytecode is basically the platform independent code because it can be run on multiple platforms. So suppose you have taken your Windows laptop, right? So there you have run the Java program, and after the compilation it became bytecode, like it converted into bytecode, right? So whenever you will copy that byte coded file in suppose Linux operating system oriented uh, computer or laptop, then you can easily run that program. But one condition is there: JVM should be there, which is Java Virtual Machine. I have already told you that wherever Java will see that software platform, in that software platform, Java will able to run or execute. So whenever in any uh, laptops or any computer, it will see that JVM, means the Java Virtual Machine, then one can easily run that Java program. So that's why we always say that Java bytecode is platform independent, but JVM, means the Java Virtual Machine, is platform dependent, right? So JVM should be there. If JVM present in any machine, then on the top of it we can run the Java bytecode, right? So after that, secured. So Java is best known for its security. So with Java, we can develop virus-free systems. So Java is secured because no explicit pointer is there. You know, right? In C or C++, we have the pointer concept. So when you will uh, learn the pointer, like when you learned the pointer concept, you know, right? So there is some memory-oriented concepts. Through the pointer, we can store something in any memory, and through the pointer, one can fetch the data from the memory. So, if we will have the pointer in Java, so we can also fetch the data from the memory through the pointers. But as this pointer concept is not there in Java, so one cannot able to fetch the data easily. So, like in other programming languages like C++, in any operating system, like uh, some runtime environments are there in specific operating system, and inside that you will install that C++ application, right? But so there you can say like there are only two layers. One is runtime environment, and inside that C++ applications, like that. But in case of Java, there are basically three layered. At the outer side, you can say like operating system. Inside that, the Java virtual machine, and inside that, Java application. So that's why it's more secure. Java programs run inside the virtual machine sandbox. So there are more security. So after that, we can say the concept of the class loader. So class loader in Java is a part of the Java runtime environment, like JRE. So which is used to load the Java classes into the Java virtual machine. So at the outside there is a JDK, and inside that JRE, and inside that JVM. That JDK, JRE, JVM concept I will discuss in the next sessions. So basically at the top you can see the JDK, the Java Development Kit, inside that JRE, Java Runtime Environment, and inside it Java Virtual Machine. So the role of class loader is to load the Java classes into the Java virtual machines dynamically. So that class loader is a part of the JRE. Okay. So from JRE to JVM, that path will be traveled by that class loader. Okay. So it adds security by separating the package for the classes of the local file system from those that are imported from the network sources. So inside that JVM, your bytecode will be there, like wherever your program, like whatever code you have written, whatever logic you have written, those things will be there. But with only your uh, program, the whole applications will not run, right? So more external libraries will be required. So those things will come from the GRE, like those external libraries will be stored in the GRE. Okay. So in this way, that external libraries and your main logical parts, those things are separated. Okay. So package for those classes are separated. So in this way, the security also enhanced. Okay. So after that, the concept is bytecode verifier. What is that? So it checks the code fragments for illegal code that can violate access rights to objects. Okay. So through the bytecode verifier, also it enhances the security. And the next one is here security manager. Okay. So you can, yeah. So there will be one space here. Yeah. So here, this is the security manager. So it determines that what resources a class can access, such as reading and writing to the local disk. So the security manager also enhances the security. So these tools like class loader, bytecode verifier, and security manager, these three things also enhances the security. Okay. So uh, additional security also can be given via SSL, JAS, and cryptography. Right. Next is robust. So the meaning of robust is strong. So Java is robust because it uses strong memory management. Then there is a lack of pointers that avoid security problems. Java provides automatic garbage collections, which runs on the Java virtual machine to get rid of objects which are not being used by a Java application anymore. And there are exception handling and type checking mechanisms in Java. All these points make the Java robust. Next is architectural neutral. So Java doesn't depend on hardware architecture because there are no implementation dependent features. For like the size of the primitive type is fixed. In C programs, in data type occupies 2 bytes of memory for 32-bit architecture and 4 bytes of memory for 64-bit architecture. But it occupies 4 bytes of memory for both 32 and 64 bits architecture in Java. So that's why. The Java is hardware independent, right? So for C, for 32-bit and 64-bit architecture computer, there are separate occupies, like separate memory occupied by the integer type. In that way, the other also. But in case of Java, that's unique for every type of architectures. So that's why it's architecture neutral, means architecture independent. Next is portable. So Java is portable because it facilitates you to carry the Java bytecode to any platform. Like I have told you, like the whenever you will uh, compile your Java program, then it will create some bytecodes, which is platform independent, and that bytecode you can transfer from one machine to another machine. And if in that machine that JVM will present, then your Java bytecode will be executed, right? Next is high performance. So Java is faster than other traditional interpreted programming languages because Java bytecode is close to native code, and it's still a little bit slower than a compiled language like C++. But Java is an interpreted uh, language, that is why it's slower than compiled languages. C, C++, those things are compiled programming languages, right? But as a interpreted language, Java is more faster than other interpreted languages. Next is distributed. So Java distributed because it facilitates users to create distributed applications in Java. So RMI and EJB are used for creating the distributed applications. So this feature of Java makes us able to access files by calling the methods from any machine on the internet. Next is multi-threaded. So a thread is like a separate program executing concurrently, and we can write the Java programs that deal with many tasks at once by defining multi-threads, like multiple threads. So the main advantage of multi-threading is that it doesn't occupy memory for each thread. It shares a common memory area, um, and threads are important for multimedia, web applications, etc. So the main advantage is like for the multi-threading is it doesn't occupy memory for each thread. So one shared memory space is there. Next is dynamic. So Java is dynamic language. It supports the dynamic loading of classes, and it means classes are loaded on demand. So it also supports functions from its native languages, that is C or C++. Okay, so automatic memory management is there, dynamic compilation and automatic memory management. Okay, so these are the main features of Java, right? So in the next lecture, we will learn about the what are the differences between the C++ and Java, right? So hope you have enjoyed that lecture. So do like, share, and subscribe for motivation. Thanks all.